Hello, 6th grade students. This is Mr. Langford here. Hey, we are going to look at Module 5, Level 3. We're going to be looking at the greatest common factor, least common multiple, the distributive property, and algebraic expressions. Alright, so we're probably going to do a few of these problems because this is sort of a bigger homework page, so we'll do a few to help you guys out. Alright, so let's take a look at number 1. Number 1 says, use any method to find the greatest common factor of each pair of numbers. So we are looking for the greatest common factor. Alright, so let's read the problem. Vincent has 12 jars of grape jam, so 12 jars of grape jam, and 16 jars of strawberry jam. He wants to place the jam into the greatest possible number of boxes, so that each box has the same number of jars of each kind of jam. How many kinds, or how many boxes does he need? Alright, so we're going to take a look, and we are looking for the greatest common factor. Alright, so I'm going to show you a couple ways to do this, alright, when we're looking for the greatest common factor. Alright, so the first one is to just sort of list out the factors for 12. So what multiplies to get to 12? Alright, so we know that 1 and 12 multiply together to get to 12. And then 2 times 6 multiplies to get to 12. Then 3 times 4 multiplies to get to 12. Alright, so that is all the factors that we get when we multiply to get to 12. Now we're going to take a look at 16. So we got 16. So we know that 1 times 16 is 16. 2 times 8 is 16. And then 4 times 4 is 16. Alright, so now we are looking for the greatest common factor. So looking for the one that sort of matches, that's the greatest. We know that 2 and 2, those match, but that's not the greatest. And then we have 4 and 4, and that would be our greatest because there's no other matches. So, how many boxes does he need? Vincent needs 4 boxes. Alright, so this is one way you can do it. And the other way, we can put our numbers 12 and 16, and we can do sort of like an upside down birthday cake method is one name for it. So we're going to put our 12 and our 16 in here, and we're going to look at what can go into 12 and 16, sort of like what we did with our factors up here. I know that 2 can go into 12 and 16. Alright, so how many times can 2 go into 12? 6 times. How many times can 2 go into 16? 8 times. Alright, I know I can keep going because these are both even numbers. And there's a 2 that can go into 6 and 8 as well. So how many times can 2 go into 6? 2 can go into 6 3 times. How many times can 2 go into 8? 4 times. Alright, so I know I can't go any smaller because nothing can go into 3. No factors can go into 4 and 3 together. So now I'm going to take my numbers that are on the outside, and I am going to multiply them. So 2 times 2 is 4. We came up with the same answers. Alright, so you can use either way. You can use the factors, or you can use sort of the upside down birthday cake method. Alright, so that's the first problem. And I personally would prefer strawberry jam over grape jam. It's a lot better, my personal opinion though. Alright, so our next problem we are going to look at is number 3. Find the GCF and the least common multiple. Alright, so on this first one, we are going to find the greatest common factor for 1 and 5. So, for our greatest common factor, we got 1 and 5. So what can multiply to get 1? 1 times 1. And then what can multiply to get to 5? 1 times 5. So what would our greatest common factor be? It would be 1. Alright, now we're going to take a look at our least common multiple. Alright, so if we look at our multiples, so if we count them by ones, 1, 2, 3, 4, 5, 6, 7. Alright, I'm going to stop there. Now if we count by 5s, 5, 10, 15, I'm going to stop there. Now, do you see a match? The match would be 5. So our least common multiple would be 5. Remember, multiples are like what you were counting, skip counting by. So you can count by 2s, 2, 4, 6, 8. Alright, those are multiples. Factors, remember, factors are what multiplies to get those numbers. Alright, now let's move on to number 5. Let's fix that there. So, number 5, using the distributive property, write an equivalent expression. Alright, so looking here, we are going to write an equivalent expression. Remember, equivalents is sort of like equal. They're like equivalent fractions, fractions that are equal. Alright, equivalent ratios, ratios that are equal. So we're writing another expression that is equal to the 12 and then times the 1 plus the 5 in the parentheses. So our first step is to go 12 times 1. 12 times 1 is, you got it, 12. And then we're going to distribute that 12 to the 5. 12 times 5, you got it, 60. Now, do I have to solve this? No, because it's asking for an expression. Alright, now let's take a look at number 6. Let's lower that a little bit. Alright, number 6 says, use the greatest common factor to factor the following expression. Alright, so it's sort of like what we did up here in problem number 3. We're looking for the greatest common factor. So I'm going to create an upside down birthday cake with 24x. And then we have our plus 32. So what can go into 24 and 32? How about 8? 8 can go into it. 8 can go into 24 3 times. So I'm going to bring down my 3 and also bring down that x. Don't forget to bring it down. How many times can 8 go into 32? 4 times. Alright, so I'm rewriting the problem. Now, can anything go into 3 and 4? No, nothing can go into 3 and 4. So I'm going to take my 8 and I'm going to put it on the outside of my parentheses. I'm going to take my 3x plus 4 and put it on the inside of our parentheses. Alright, now remember, we're writing an expression, so we do not have to solve the problem. Alright, we just have to write the expression. Let's move on to the back side. Alright, we are going to take a look at, let's do number 7. So write the terms in the box that describes them. Alright, so we got the x squared terms. So which terms describe the x squared? So we got 4x squared and x squared. So we have 4x squared and x squared. Our x terms would be 3x. And then remember, our constants, those are the ones without any variables. So it would be 5 and 2. Alright, very good. Thank you for following along. I'm going to leave the rest for you guys. Don't forget, whenever you're doing your vocab, make sure you are looking up your vocab on the 6th grade math website. It will help you. Alright, thank you for joining me. I hope you guys have a wonderful day and enjoy the rest of your afternoon. Thank you.